Hey everyone, welcome to another wonderful edition of Demo Days. Nice to see everyone up in the chat. Bonjour, hello, good morning, good evening, good afternoon, good night. Nice to see y'all. Good to see everyone. I see some folks from Russia in chat. I see folks from India in chat. I see folks from all over. Yes, it definitely a Friday live stream today. We are going to have an amazing day today. I've actually got some really special guests for all of y'all today. So I'm going to bring in. Oh, I think I still hear some music in the background. Let me kill that. Yep, you know me. Always audio issues, but hopefully we're good to go. Bonsoir. Hello, hello. Yes, super pumped today. All right, let's bring in our special guests and I'll stop delaying. All right, Kerim and Taylor, our friends from HashiCorp, welcome and thanks for coming on to Demo Days here today.
Thank you for having us.
Yeah, why don't you introduce yourselves and tell everyone why we brought you over here from HashiCorp to our GitHub Demo Days.
Absolutely. So my name is Kerim Satirli. I'm a senior developer advocate at HashiCorp. We're focused on the infrastructure line of products, so Terraform, Packer, and a lot of GitHub repositories. We do fun stuff, I think, and I'm here with my colleague Taylor.
Howdy, everyone. My name is Taylor Dolezal, and I am also a developer advocate at HashiCorp. I'm also focused on infrastructure, so again, Terraform, Packer, and the like. I also focus a little bit on application delivery as well, so working with tools like Waypoint and making sure that your clusters are operational and running are some of my favorite things to do. And we were asked to come here today because it sounded like somebody wanted to do a Friday deployment. And obviously, Kerim and I kind of jumped at that. You know, we had a shortage of that being developer advocates. So it sounds like fun to me.
Yeah, I gotta say, if the deployments are as good as the background music, this was beautiful.
I was going to say, listening to that, I'm surprised that no one has come out with a. I know there are those several permutations of chill wave listening to music with all of the different title cards for those. Surprised that no one has made one with Octocat just yet, but maybe soon. Maybe soon.
See, you're putting ideas in people's minds. I like it. So we'd like to talk to you about iterative infrastructure. And specifically, that really means that we want to show you a couple of slides really quickly just to get a base understanding, because we see so many people in the chat. Y'all look great today. Most of you anyway. Some people, nah, I'm kidding.
Bedhead.
Y'all look great. It's early, right? I get it. So thank you for having us. I think we've done intros, so let's talk about infrastructure as code. And do you want to do this one?
Yeah, absolutely.
Also, perfect. Let's do it.
So in today's session, before we start diving into some code, let's talk about, what are we actually going to be doing here? So we're going to be talking about infrastructure in the IT sense, so servers and the applications we run on those servers and the configuration that's needed to run those applications. More specifically, we're going to be approaching infrastructure from a code perspective. So simply put, infrastructure as code, or IAC, as you might have referred to it or heard it referred to as, is the process of managing and provisioning resources with machine-readable definition files. So what does that mean? It means that instead of manually going and configuring things via UI or an admin dashboard or clicking buttons, you're going to be setting that up with code. So when we talk about resources, we're going to be talking about virtual machines, security groups, network interfaces, and software-defined storage options. When you think about infrastructure as code, you can think of it as executable documentation. It's human-readable, but you can execute it with an application like Terraform. Infrastructure as code is an enabler for many good things, of which I'm very excited to show you today. Provides a codified workflow so that you can commit your work and version it. And then because it is code, everything you love about version control also applies here as well. You can collaborate with other engineers, you can roll a change back, submit a new change, and easily spin up an additional set of resources by using things like Terraform modules, for instance. Most importantly, because everything is written out, you can spin up those resources in a safe and predictable way, which, again, sounds really great for our Friday deployment here. Code is obviously a very big part of infrastructure as code. It's literally in the title. And there are a handful of languages that you can use, such as JSON and YAML. For today's session, we're going to talk about HCL, or the HashiCorp Configuration Language. The HashiCorp Configuration Language, or HCL, is a common language supported by all of our tools. But rather than talk about HCL, let's take a look at what it actually looks like. So as you can see here, we're going to pop up our terminal. We've got a service of type HTTP. We gave it a name of web_proxy. We've defined a listen address for localhost, and then a process called server, which runs a specific command. As you can see, HCL is both human readable and machine readable. And this syntax is something that you can pick up in a few hours and use across all of the other HashiCorp products, which is really helpful if you want to jump into Nomad or Packer. Today we're actually going to show Packer using HCL, which I prefer to JSON personally. Now I know that was quite a lot in a very short amount of time. So here are a couple of dog pictures for you. Take a breather, take in the sights of these wonderful animals here. Some of my favorite pictures of some of our favorite dogs.
I mean, they're literally our dogs, which is why they're so amazing.
That's why they're the best.
So while I get set up for code stuff, let me quickly switch my screen off so you can look at us. If you have questions, feel free to leave them in the chat. If you don't feel like leaving questions in the chat, or the great ideas come to you right after the session, which always happens for me, we're only Dole and @Satirli on Twitter and pretty much everywhere else. So if I haven't responded to your pull request, just feel free to call me out. It's totally fine.
Yeah, most people say don't @ me, but Kerim is like, no, go ahead, just do it.
You absolutely should. So quick check. We've got our editor up, and AJ, if you can get that into the stream, can you see this? Basically what you should be seeing is an editor interface on the left side with some code, and a terminal interface on the right side.
Fantastic. That looks good to me. I think
Awesome.
the terminal on the right might be just a hair too small, but besides that, I think everything
There we
looks
go.
good. Fantastic.
Updated. So when we talk about infrastructure as code, we obviously talk about code, and we want to show you a few cool things with Terraform. And since it's Friday, the first thing we're going to do is create a GitHub repository. And to show you that this is all live, let me open Safari. And we have the demo organization here. As you can see, no repositories. So let's switch back to our editor. What you see on the left side, these 8 lines of code, is Terraform. Same code type that Taylor just showed you. Here, we're grabbing a provider, specifically the GitHub one, which makes a lot of sense, right? We want to start out with a repository, maybe some team memberships, and we'll define that. If you've never used Terraform, totally cool. You've probably used something like NPM or any other package manager. Think of this as your package JSON. We define the versions, we define what module or provider in this case we want, and we go from there. And so this is already part of the first Terraform workflow. You define a provider, you run init, and on the right side of my screen, you'll see that Terraform is actually grabbing the provider from the public registry. Now, while that happens, let me switch to a different file. What you see here?
And it looks like we're getting a couple comments on zooming in just a little bit more.
Absolutely. On the code side?
Correct. I think both code side and... Awesome. How does that look for everybody? It's funny that with everything that's going on in the world and being on Zoom, when people say Zoom in the chat, I'm not sure if they're on a Zoom call or...
It's been, yeah. Here we go. We'll make it a little bigger. The good thing about this session is that this is actual real life code. This is not just an animated GIF. So afterwards, we'll share the repository URL with you, and you can look at it on your side, which is even better because that means you can try it out. So back to our code. We've grabbed the provider, which you can see on the right side of my screen. Everything worked out. Everything was downloaded. I'm going to go ahead and clear my terminal to make it easier to see what's going to happen next. And back in the code editor, we're defining our code here. We've got the demo organization. That's the one I just showed you. So here, again, no repositories, just Taylor and myself in there. And so let's start out by making sure we actually have some admins in there. Taylor, you feel like being an admin today?
You know, I don't think I'm doing anything else this afternoon, so that sounds like a good job for me.
Beautiful. So you're only Dole on GitHub. I'm at Satirli on GitHub. So I've added us to our organization admins. It's a list in Terraform. Again, really simple syntax. So we'll grab that and we'll throw that into a membership resource, which I'm going to call admins. And I'm going to iterate over everyone here and just say, let's do this. Let's first do a plan to show that we're actually going to be doing a little bit more. But if you notice, Terraform already understood that it doesn't need to do the membership because we're already in there. And we've obviously previously tested this. So while we skip this, let's go and create a repository, which really is the coolest part. So on the left side, just like we showed you before, another Terraform resource, this one of type repository. And what's really cool about this is that we've got it written out over 26 lines of code, but you could probably have it in about 5 or 6 lines of code. You can codify all your GitHub repositories. Now, if you run a personal GitHub account, you could say, you know what, that's too much work. 5 lines of code is way more time than it takes me to just click in the UI. And I get that. If you're doing this for an organization, this is a lifesaver. And I mean, because we're live here, I just got to say, Jeremy Kudid, who's working on this provider with a couple of other contributors, thank you so much for the work. GitHub is absolutely my favorite Terraform provider, and Taylor will prove that. It is literally the first thing we do is go in, set up their organization, set up the repositories, and make sure everything is nicely codified. Because if you have repositories, then you can do all the good things that you can do with IAC.
It's really helpful too, being able to codify your repositories out like this. Typically, a lot of patterns that I've seen used in the community have been people creating kind of a repository to spin up their other repositories. With infrastructure as code, you do typically find yourself in a situation where you might have, chicken and egg situation where you have to, unfortunately, manually create, that repository the first time. But then once you do, you set yourself up for a lot of success in the future, being able to, add repositories and then configure things in a very broad way. If we wanted to make all of our repositories private, we could go ahead and do that. Public, we could go do that. And then this also allows us to check to make sure everything is all right in a PR process, collaborate with others, make sure everything looks good. And then, recently GitHub allowed for us to change from master to main. That makes this very easy to do with infrastructure as code as well. So I'm a huge fan. I could probably talk all day about the GitHub provider specifically, but we have other things to talk about, but very helpful.
We definitely have other things to talk about, but one thing that you'll really love if you're that kind of person, you can disable and enable various merging strategies, right? I'm a huge fan of squash merging, mostly because we do a lot of exploratory commits, I think is the PC term. And by squashing them, nobody ever gets bothered by all the cruft that happened. So we've got a repository. I think all looks good. On the right side, we can see Terraform on plan tells us that one resource is going to be added, which is absolutely correct. So let's go ahead and apply this. And so just to be sure, Terraform verifies once again with us, is this really what we want? Now, in the sense of a GitHub repository, there's no cost attached, right? Imagine you're doing other type of infrastructure, like a virtual machine or maybe a GPU-heavy instance. You might end up spending a lot of money if you confirm this and don't actually want that type of instance. Could happen, not what we want. So in our case, we're gonna just confirm and wait for the API to do this. Takes about 10 seconds, which is beautiful. Yes, that's 5 seconds longer than you could click in the UI, but I also have it as code now. And again,
I think the 5 seconds is clicking the button, and then the other 5 seconds in the UI is typically the waiting for your repository to load up.
and figuring out what to call it, right? So as you can see, our first Terraform deployed repository, beautiful. We've got one for Packer images. And that actually takes me to one of the questions I saw pop by in the chat. I don't know if AJ can actually find this one back, but it was about code organization and how you would normally organize code. Exactly that one. Wow, that's beautiful. So the reason we have all of this code in one repository is mostly to make it easy for you to download it. And to make sure that we can depend on the other repository or its subdirectories in here. Depending on your organization, a monorepo approach might not be the best version, or the best way of doing this. I myself like splitting these things out because it makes the blast radius smaller, but I know everyone has different approaches to that. So, Taylor, what do you prefer? Monorepo or just
I typically like,
sprawl?
I really do like breaking it out. I'd say, working with you on this demo and this code, it was definitely different. Typically, I won't follow a monorepo approach, and it became interesting when we integrated, GitHub Actions and some other things around this project. But I have seen a couple people set up their code structures such that they'll create their base modules or things that they're testing, some modules that they might be testing, and then breaking out the configuration for different environments into different folders. And then just kind of importing that in, again, using local files or modules. I personally really like breaking things out, like you said, into different repositories, which allows me to then have different Terraform states and not, break things as I set them up. You can get into a bit of a problem if you start to reference state of other, repositories, things like that. So it's just one good thing to be mindful of. If you're in that kind of situation, you might be able to leverage tagging and other ways and data providers within Terraform to start to reference things and look things up, which is the best way I've found around that. But typically, I will like setting things up in a microservice-y type approach, and then it makes it a little bit easier to kind of like focus on that specific thing instead of worrying about breaking some other dependency or something else within a monorepo. But
I think that's actually beautiful, right? Like splitting it out like that, you just limit your blast radius, and especially if you're new to infrastructure as code, in general, if you're new to a language, the less you can break, the better. Obviously, all these tools, all infrastructure as code tools, try to make it easy for you to not break things. But at the end of the day, if you're going to ask your application to deploy 100 servers, it's going to confirm with you. And if you hit yes, then there you are. So let's see if there's any other questions that we missed. I think not. Cool. So let's move on from our Terraform code for GitHub repositories to one for Azure. So we've created a repository for our Packer images. Of course, the logical next step would be to test it in GitHub Actions. But we first need to actually be able to have some code to run it. So what we'll do is we'll use Terraform once again. And if you're following along with the repository, I don't know if we can get a URL for that shared in the chats or if we'll share it later. Sure that there's going to be a way for you to find this. We split this into a different directory, again, for the same reasons that Taylor just mentioned. So what we're doing here is we're instructing Terraform to download 3 providers, specifically the Azure provider for Azure Cloud, local provider, because we're going to be doing some local stuff on our file system, and the random provider for reasons I'll get to in a second. And so if we switch to this one, on the right side, I just switched my shell to the Azure directory, which has the code that you see on the left side. So specifically these 3 files. And I'm just going to run a plan to show you what we're doing here and give you a basic idea. And so right away, you notice that we have 2 random things popping up. One is a random pet, dinosaur, which is obviously the best possible pet that you can get. And the other is a random string. And so you might be wondering, why do we need those? And that's actually, just realized that's no longer part of the demo because we removed that a little bit. So we're leaving the dinosaur in there because it was so beautiful. This is the beauty of doing things live. Sometimes you come across code that's dead. We need to up our PR game. Make sure we don't have this in there. So moving on from that, we're just actually going back to the one resource that we define for Packer to be able to build images, and for us to actually need a repository to put our Packer code in and then run actions against. We first need an Azure resource group. I'm in Amsterdam, so I built my stuff mostly in West Europe. We're calling our group Packer, just to keep things simple. You can call it whatever you want, as long as it makes sense to you. We could, obviously, use our beautiful random string that we just generated. So let's actually go ahead and use that. And what you see here, we use this with storage accounts. So what we initially did was grab a random pet and then added a random string to it to make sure our our storage account always had a unique name, because these have to be globally unique. So if we go back here and let's do this. We've just updated our resource group name from Packer to Packer Dinosaur EHW2. And we're just going to see how Packer responds to that. Sorry, how Terraform responds to that. And you can see, because we've deployed this group before, Terraform actually knows that we are indeed creating a new resource. Resource groups can't be renamed. So in this case, they need to be replaced, which is what we're seeing here. Now, for the purpose of the demo, doesn't really matter, so we're not going to go ahead with that. But one of the cool things is that we also write that information from Terraform in a format that Packer can use. And we'll get to that in a second. And so essentially what we're taking is we're telling Terraform dynamically grab the reference of the resource group, and then what we want is a location and a name, and write those to a file. And that file is terraform_data in a format that Packer will automatically load. So let me show you how that looks like. And you'll see here, very simple. We have a key value format. There's nothing special about that, right? Except for the one thing that if I actually apply this change, which might take a second because everything is live, you'll see that our template file will get edited and updated with the new resource name. And the beauty of that is that we're now driving Packer configuration on this approved. We're now driving Packer configuration from Terraform's knowledge of our infrastructure. And in the meantime, you can see on the right side that Terraform is cleaning up our old infrastructure by removing the resource group, and it's going to add a new one. And sometimes that takes a while because we have a couple of resources in there. But while we wait for that, there we go.
One thing I did like too is that, so if you notice when Kerim did the plan and the apply, when you got that feedback from Terraform, we're using Terraform 0.14, which is the latest, generally available version that we have right now. And with that came concise diff. So if you haven't seen that before, it's really a great feature. It eliminates a lot of searching for what changed, or what's going to change when you're running a plan. So as you see that, you can see, it'll say 3 resources that not changed have been hidden, or 3 attributes not changed have been hidden. So if you do change resources using Terraform that have, like a Helm chart is one thing that has a lot of information. You don't want to see the things that didn't change every time. Concise diff is really helpful on that front. So if you're not on Terraform 0.14, that is just one of the many fantastic reasons to bump to that version, if you can.
And while we've been trying to give you interesting and relevant information, we're still waiting for the resources to be destroyed. And I had a quick look in another window. The reason it's taking a little while longer is that in that resource group, the Packer resource group, we have a couple of resources that are now also being shut down as part of the removal. We're not going to wait for that because nobody has time for that. It's Friday. I know you want to see something more interesting. We're just going to let it run in the background. And in the meantime, we'll go to our Packer interface and just making sure code size. Can we all see what's happening on the left side approximately?
I would say bump it up just 2 more increments. That might be.
Yes.
That's much better. Much better.
There we go. Beautiful. So as Taylor mentioned, HCL, or the HashiCorp configuration language, also works with Packer. So despite being in the same repository, we've actually switched to an entirely different tool where Terraform deploys infrastructure for you in the broadest sense of the word. Also in the broadest sense of the world, definitely. Servers, databases, DNS records. Packer focuses on building images, specifically machine images. You can do that for Azure, AWS, Google, but also for a couple of other providers. And so in today's image, what we're going to be building is, what are we building today? Pretty sure it's an Ubuntu base image that we are just updating with the latest changes. And let me find my code for this. Yeah, definitely. Ubuntu server. We've got all of this in the repository for you, so you can work along. None of this ends up costing a lot, especially if you have a new Azure account, which comes with a couple $100 in free credits. So definitely give this a try. And we'll start out with our image definition. So you might be wondering, hey, wait, I see you all define everything statically. That's not cool. It's going to take a lot of time. Well, the good news is we don't have to. We're actually defining our whole build strategy here in terms of what the base image is, who's making it, which version, and where in variable files. And so what's useful about this is that I generally build my stuff in regions that are close to me. In Azure, for example, that would be West Europe. Taylor might be wanting to build something in the US or specifically on the West Coast. So we could just go in and find that property somewhere, which is, of course, in the file that we git ignore. So you can see, beautiful. Terraform actually completed the long-running task. Yay. So it's beautiful, right? Friday deployments that work. And there we go. Now the file is actually here. So you can see we had Terraform fill up this file for us, added Western Europe, added the new updated resource group name, and we're good to go. So I wrote some Packer code, and I generally, when I run this locally, it's really hard to type with a microphone in front of you. I'm still looking at my keyboard. Been in IT 15 years, it's fine. So while we are doing this live demo, what we're building is an image with Packer, Ubuntu 18.04, the server edition on Azure, and our code looks good. I just run Packer format, which if you know Go FMT, Terraform FMT, just to be real, we live by this creed. Always format your code. Code quality is important. Then you know this works. But it's Friday, right? So you might go like, you know what? This is beautiful. My code looks good. I'm going to skip the format for right now. And we're just going to do this live. And I'm sure there's nothing ever to worry about. So let's do it live, or actually add a new branch. We're going to call this hotfix, which you can't see in my window, but I just switched to a different GitHub branch, Git branch. And in my Packer file, I think this one was going to be called image published. And we're just going to say fixes image reference. So we're building infrastructure for our team to use. We've got an Ubuntu server. We've already deployed it once. And my colleague just called me up and was like, hey, look, this repository had a little bug. I would love to see what happened. And so let me zoom in here a little as well. What you could see is I just updated our base code to image published. I know that's wrong. That's okay, because hopefully our GitHub Actions will catch us and alert us. Friday, let's go. Can you approve?
It's like somebody's clearly ready for the weekend. And
I don't get why this was broken in the first place. I mean, it looks good to me. Published is a real word. My editor didn't pick it up.
Yeah, it's fine. It's fine. It's great too, because if you start to use things like GitHub Actions and you codify some of your approvals when it comes to your PRs, doing some static checks, you can really help yourself out, help future you out. And you can run things like format or validate and different parts of the process so that you don't have to necessarily pull the code down, check it, especially if it appears to be more of a simple change. You can create some unit tests and other things that really help you out. And so that's what we've done here inside of Packer, is run a format to see if everything looks good.
The Terraform one is actually also breaking, and we should get into that in a second. And Superlinter is also still working. So while we wait for those to execute fully, you can already see at the bottom of my screen some checks were not successful. That's what we expect, and that's actually what we're hoping for. So in order to show you what we can actually do with Packer, I'm just going to fix this once again. And oops, typo. The cool thing is we've got this whole GitHub workflow codified for you. So if you grab the repository, I think Taylor Yori shared the URL for that. You can just copy it into yours and have Packer linting, Terraform linting in the form of format and validation ready to go. And that's honestly the best way to start the weekend. And if Terraform or Packer come back with a lot of errors, it's a great way to start next week.
Give yourself something to do next week.
Yeah. So pushed a new version of this, and pretty sure the Terraform code is still failing, but at least there we go. Packer by now successful in 13 seconds. Man, the speed of this really got a lot better. So we're grabbing a GitHub action here, specifically one that Taylor and I built, which also gets some community contributions. So if you are one of the people that contributes to this GitHub action, thank you so much. Contributing to open source is never free because it always costs somebody's time. So I definitely appreciate it. I know you do too, Taylor. But in the meantime, let me show you what we are actually doing here. Maybe not the less interesting part of actually pulling the file. So we've got Packer here, which we're running, and we're validating our file. And there's a lot of code here to be seen, but the most important part is the highlighted part. We did a syntax only check. We formatted and validated, and the GitHub action told us everything looks okay, which means we don't actually need to block this pull request. And that's pretty much what you want. I make typos all the time. My editor usually catches most of them, but definitely not all. Because at the end of the day, no editor will ever be as good as the tool you run it against. And by having this kind of stuff codified in your GitHub Actions, you're making your life a lot easier. So we'll get to the Terraform part in a second. But in the interest of time, let's see if we can live build this image. I think the first one might fail because it already exists. Let's give this a second. Oh, wait, we haven't deployed it in this region yet. Awesome. Yeah, I really get happy and excited when we do stuff live and it works out. Get some, we're definitely not running these GitHub Actions locally. Mostly because there is no specific reason for us, and also because we like doing it remotely and making sure everyone on our team has access to them.
I had a good laugh at live demos are very scary. Absolutely agree with that. That's why we're so excited to be here today, is so that we can kind of share some of these GitHub Actions with you. GitHub Actions are really versatile because I don't know of a good way to run them locally. I know there have been some developments, literally, figuratively, made on that front, but you can host your own GitHub runners. There's great documentation on how to do so. If there are things, if you're on a private network, depending on your infrastructure, you have a lot of resources available to you on that front. The GitHub Actions that we're working with today can run on any GitHub instance. So if you have GitHub Enterprise, if you're just working with GitHub, you can use these actions. And then we, in total, we'll kind of get in more into this the code in a little bit. But the 3 actions that we have specifically today that we're running are Packer, which you saw with what Kerim was doing and making sure all of that syntax looked good and was okay. Just really a static check. Terraform, which is going to be doing the same thing. It's just going to be doing some static checks. It's not going to be handling the plans and applies specifically. You can do that, though. We do have a couple examples, which feel free to at me. I've got some examples of a PR process that will actually post back comments and let you know if the plan succeeded, failed, who actually made the code contribution. And then lastly, we had Superlinter, which will go through and handle one of my favorites, honestly, provided by GitHub, is that it will go through all of the code in your repository, and then if you specify, I want this to lint for Bash, I want this to lint for Markdown, Terraform, it will go ahead and scan for all of that, and then you can configure your own rules. Like Kerim said, I'm also a serial typoist, and so I'll make mistakes all the time, and that linter will help me write better code and have better code quality.
So while Taylor was talking, I started the kicking off of the Packer build image, and we're getting there. Most of it looks green. We had a couple of errors, nothing important. We're also, for this build, going to ignore those errors because they weren't important to us. Also, note of advice, if you're building images, yes, Packer will check if your exit code is good, but it can never verify if everything you try to install actually installed in the way you want to do it. There are other tools for that. I definitely recommend checking whatever you build and never just trusting one source to do it for you. So in the meantime, while we wait for the Packer image to build, and what that involves is essentially Packer starts up a VM in Azure. It runs the base image that we instructed it with. It runs a couple of commands, and once it's done, it captures that image and stores it. It's a little bit of a time-consuming process. I'm guessing will be 5 to 6 minutes before we're ready. We are going to be looking at some of the code in Terraform that we want to use to start up that image in whenever it's ready. And so, as before, we've got, let me actually show you, a very simple repository. We only have the Azure provider in there. And you could do this with any other provider. In our case, we're building the image on Azure, so we need to use the Azure provider. We're defining a virtual network, public IP, a couple of other things. And you notice there's a local variable that we're referencing. And so what you'll see, these local variables actually use a remote Terraform state. And so what we're doing here is we're grabbing that code. So the same way Packer got a file generated from Terraform, we're actually using the Azure subdirectory, which has its own Terraform state, or in this case, Terraform Clouds state, to retrieve those values. And by referencing them in this way, I don't have to update the resource groups in 3 different places. I don't have to update the location, which was one of the options. It's all defined in a single place, and everything else just pulls from that place. Very, very powerful, because it means less places that need updating, and it also means less code maintenance required. So we've got our network. We should do some compute stuff. So what we're going to do here is, first of all, we're building a Packer image. And let's see how this is going. Oh, it's actually pretty far along. Good, beautiful. We're going to tell Terraform to look for the Packer image in our Azure account. And because we only have one image called Packer, it should find it. We're going to start up a virtual machine, which we're going to start with our local SSH key. And word of warning, Till and I didn't really consider how this would play out. So while this uses our local SSH key, Till's local SSH key and mine are not the same. Which means if you want to do this with multiple engineers, either you all have the same private key, would not recommend, or you figure out a different way to do this. It's actually a super easy exercise, but it's one that will get you thinking about how to do this. Or just consider that you will never want to log into your image, into your machine, and just don't add an SSH key. So for the virtual machine that we're starting up, we're grabbing our Packer image, which will be dynamically retrieved. And we're going to be outputting some things here. And let's see if we can actually do that. Awesome. 6 minutes, 23 seconds to build a new image that my whole team can now use and start up 100 or 1,000 virtual machines from. Pretty good deal. So in the meantime, let me update my Terraform code by changing a variable that I know will break. And I know that it will break because my editor is already telling me it's incorrect. But Terraform format doesn't detect it because it's not misaligned. If I run Terraform validate, we have a reference to an undeclared resource. But it's Friday, right? Nobody has time to run validate. So we're just make sure, are we? Yep. Base reference. And if we switch to our browser, Oh yeah, still use the hotfix branch. So you can see here, hoping this is big enough. We changed Azure RM to Azure. It saves us 2 characters. Why would I not do this? Storage isn't free. And you can see this is running since 30 seconds. And let's see what the check is saying. Let's go here because that's nicer. And so this is the Azure Compute directory, and we already see a bug there, or a warning. Aha, so the first one is we're trying to pull a public file that is not actually available everywhere. Specifically in this case, the GitHub Actions runner doesn't have that file. Was this expected? Of course not. It worked locally, right? Like, it worked on my machine. It's going to work on Taylor's machine, but it might not work in our deployment setup, which might be GitHub Actions. So maybe for this file, we're going to use something different, but we already see that this is definitely a problem. So let's go ahead and can we remove the public key here? It's a good question. Actually, let's look this up real quick.
And you'll notice that with the repository that we shared today, you'll note that all of the Terraform state is stored locally. And so you can use things, we typically recommend a remote state if you're working on things for production or environments that people might run applications on, just because that's a lot safer way to do it. But for, just for showing off a demo or a feature, using local state will, that's a really good place to start. What's really nice is that Terraform Cloud is a great, they've got a free tier. It's just a fantastic option to get started and very easy to store your state remotely and then start to audit changes. I believe it's free for about between 1 to 5 people, if I'm not mistaken. And so you can start to scale that up with your team if ever you wanted. You start to get more people in a project. You really like how that works in the workflow, and you can continue that forward. But really helpful here. And then that's where the back end remote, when you saw that remote state get referenced to, that's what that was in reference to. So if you've any questions on anything today, feel free to throw it in the chat. I'll be more than happy to answer on that front.
And so, yes, we thought about this before. So to make this easier for you, we put in links to the actual resources that we're using, which allow us to do a quicker lookup. I made a quip saying storage isn't free, but realistically, the more you comment your code, the easier it gets. So we leave helpful little comments in there for you. And as it turns out, if we specify admin password, we don't have to specify admin SSH key. So if you could all just not look at your screen for a second, I'm just going to type in my very secret password here, which is password that doesn't know, exclamation mark, because, security guidelines. And let's do a Terraform validate. Oh, man, there's some rough comments in. Yeah, I can't comment on that.
It's really funny.
So in the meantime, Terraform is still telling us that our resource is incorrect, and that's absolutely correct, but it's Friday. We're still going to ignore that. So updated password. Cool thing about hard coding the password is that everyone can see it, right? Like, I don't need to tell my team what the password actually is. And if, jokes sometimes don't translate well through webcams, that was absolutely sarcasm, and you should never hard code your passwords. If you need a password manager, HashiCorp makes Vault. There's other tools that most cloud providers provide as part of your cloud. Any of those is a better option than hard coding your password, which is what we've just done. And as you can see here, let's see, we have a Terraform. Well, we have an error in our GitHub action. Terraform format is not checking out. Probably also because I misaligned some stuff. Man, it is really Friday on this, isn't it?
See, that's what we do without our GitHub Actions.
And I'm kind of glad it caught both of those, because as a human and as somebody who's been using Terraform for a long time, I did not catch this. But the good thing is, because this is failing, Taylor won't be able to approve my pull request. And that's really what Fridays is about, right? Don't merge pull requests that have failing GitHub Actions. Because if you do, your Saturday becomes your Friday. And then your Sunday is really your whole weekend. And Monday is not going to be fun either. So while we fix all of this, and I know nobody has been looking at my screen when I had the password up, so I'm just going to scroll that away because that's way better. What other bugs do we have in here? This one.
I did see one question by Verify, and it was, would you agree with having a build agent like Jenkins to store the state remotely, as well as it being the sole automation user to deploy items to different environments? Great question. Typically when you get started with Terraform and when you're trying some things out, again, you can store that state locally and kind of like get a handle of what's going on and try to understand it. It's always best to understand something before you go do it. I know that sounds really obvious, but something that we forget a lot. A lot of people will typically jump into the code and not really give things the thought that they really need. It's okay to get up from your desk, take a walk around, and just kind of like ruminate and think on things. And so absolutely recommend doing that. I know I definitely have to practice what I'm saying as well. I'll forget to do that at times too, but it's always good to have an understanding of what's going on. So when you have that figured out and you're working with a team or pushing that to a production-like environment, it is best to have just one runner for that. So that's, again, where Terraform Cloud can help out. Or if you set up some CI/CD, just having that be the thing that's running the actual applies for everything. Typically, you won't want to let open up the floodgates to everybody being able to apply, right? Because then you can run into some issues there. So that is a really good pattern to just have that single type of apply, and then like Jenkins, GitHub Actions, anything like that would be a good thing on that front. We also got one more question I'm going to answer really quickly from Pablo. Do you recommend having both infra and deployment templates as part of the application repository? Personally, my personal preference is breaking that up, and so having different layers of infrastructure, like say if we were working in a cloud, we need to set up a virtual private cloud. There are a whole bunch of really great modules on the Terraform registry we could take a look at and utilize. I'll set that up in one layer and then tag that appropriately. And then if I'm setting up something like an AKS cluster or something to deploy my applications to, I can reference the labels and the tags and use Terraform's data lookups to kind of see what's going on there, or data sources to see what's going on there. So really, really helpful on that front. When you have a mono repo, it's easier to make a change somewhere and then kind of like clobber other changes, or have a problem with Terraform state. And so breaking that up can make it a little bit easier and give you a better blast radius around the changes that you make.
And so, as you notice, there were a couple of other errors that crept in as I was talking. I hit spacebar. I had some misaligned code. I know Taylor takes code quality really seriously. He wants all my code to be correctly formatted. I get that. Sometimes I forget. That's why we have GitHub Actions that we can run against this. And so far, 21 minutes in, my change is actually starting to look good. If we find the right tab. So far, 2 of the 3 or 3 of the 5 are green. Actually, 4 of the 5. This is beautiful.
Yes.
I might have a Saturday after all.
Super linter does pull in all of the linters, I believe, and so that's why it can take a little bit longer. A lot to pull down, a lot of code to sift through. So definitely, I think that once the code looks good, that's typically the GitHub action I've seen run the most quickly. And so
talking about superlinter and the other GitHub actions, we've got the code in here for you. Specifically, Packer YAML has all the Packer stuff, as you would expect from the name. We're essentially formatting and we're validating and we're doing a syntax only check. And that's mostly because we don't want to try and test our deployment right away from GitHub Actions, because for that to work, we would need to give our Azure credentials to GitHub. And if you're running GitHub Enterprise, that's a whole different world, right? Like you have much more control over what happens. In our case, all we want to do is make sure our open source image that we're going to share with the world has good syntax. We'll also be deploying it in other ways and validating it that way. But for this action and for something that you can use all the time without having to add your credentials, this will work. Same story pretty much for Terraform. We're doing a matrix build against the 3 repositories that we have in here. Sorry, the 3 directories. And that's really cool, right? We're spinning up different agents, making sure it all runs super quick. Feedback has been great. I think from start to finish, we're at 23 minutes. And I managed to break and unbreak Packer. I managed to break and unbreak Terraform multiple times. Well, I only unbroke it once, but definitely broke it multiple times. We validated specifically our pull request. We format pretty much everything. And we make sure that our output reflects what's going on. And this is beautiful, right? You don't need to think about this anymore because your repository does for you. And then finally, superlinter, Taylor already mentioned, we're running it against our code base. In our specific case, we validate against Terraform. We also validated our YAML, of course, the GitHub Actions. And we don't disable for errors.
One thing that's nice too, really quick, Kerim, if you wouldn't mind going to the top of that GitHub action, is so if you can see the on stanza there, that level, GitHub Actions are really helpful because they're made inside. They're made for GitHub, and so you have access to everything inside of your GitHub repository. If you wanted to run an action when somebody opens an issue, and you run an action to help triage that or add labels, you have the ability to do that. If you want to do it for specific branches, you can. Here you can see on pull request, we don't outline which branch we want to use because we want all of them. If people create a feature branch and then submit a pull request, we want this action to run. So there are a lot of cool things that you can do here. I made a note for myself to go check. I believe that there is the option to do something when somebody stars a repository. So it might be fun to send an email or do something like that as somebody stars your repository. Maybe make an update to your README and commit that. Something fun on that front. But lots of interesting ways that you could go about extending GitHub Actions. And then, again, the Packer action that you saw today was made by one of the people on the stream. And, thank you for all the others that have contributed. But it's fun to be talking with the maintainer and and get to use that action live for all of you today.
Yeah, I think with all of those things, and whenever you think about contributing to open source, think about what itch you could scratch with your code. Because I guarantee you, when I built that action, I was like, you know what? Nobody's going to use that because otherwise somebody would have built it. And I get pull requests, I get suggestions from people. It's super fun. And it's also nice seeing people actually use it. So let's go through a couple of questions as we have a little bit of time left. Let me see. Superlinter should definitely be a requirement for graduating college.
I absolutely agree with that. I'd like to see superlinter certification. That'd be a fun one to add to your LinkedIn profile. One that I kind of want to ask you as well, Kerim, is by Get Some was, do you agree with one person as a gatekeeper to accept, allow changes, or do you have an open culture where multiple people have the ability to accept changes and deploy? Personally, I think that it's always difficult when you have one person. Typically, it's better as a set of people or just as a team in my opinion, to be able to approve that. I think that creates a better culture. Because say you have that one person as the person that's approving things. What about when they go on vacation? Oh, I never go on vacation, that person might say. Do you, but what about if you get sick? If something happens in your life and you're just not able to pay attention to that repository or fulfill those duties, maybe it's Saturday, maybe somebody's working that day and this is something that needs to go in. This is a hotfix and it's critical. Typically giving the whole team the ability to approve is best. Get your team's eyes on it. Typically it's hard to see if you've made a mistake yourself because you're too close to it is the terminology. But having other eyes and more views is always better, in my opinion. Do you feel similarly, Kerim, or do you have anything to add on that front?
So when you think about infrastructure as code, it's a huge part of DevOps, right? And I think one of the core principles is CALMS, CALMS, and the first letter, C, stands for culture. And to me, this is really a culture question. It's not just about being able to go on vacation. It's about being able to trust your team. If these are the people that built the same infrastructure, I should be able to trust them to deploy. I shouldn't need to go through a single person because that it removes speed from the process. It also means that we still keep a human element in there to say, hey, this is good or not good. And I think that's dangerous because humans are faulty. We get constantly version upgrades, but still there's bugs galore. So in that sense, it makes a lot more sense for a team to be able to say, we've got these many checklists that we run through automatically on every pull request and on every merge to our main branch. And if that checks out, awesome. You should be able to deploy it. Doesn't mean you can't have gatekeeping in the software, like say, let's not deploy Friday 9 p.m. because sometimes still things slip through and go wrong. But yeah, you can definitely approach this from different ways. And yeah.
One other question I saw by GetSome was, once you commit a secret or password to GitHub, you can't erase it, right? So one thing to be mindful of is that while GitHub Actions do a fair amount of scrubbing from the logs, that is one thing that you definitely want to be mindful of. If you put a password in there, or if you've made a repository public, the previous runs can be seen. So if you do have any sensitive information in there, that's definitely something to be mindful of and getting that cleared out. When it comes to secrets in the repository, if you're storing something as a secret, that will automatically get scrubbed out, but which is great. Secrets dot, and then if you put like environment variables inside of your GitHub repositories. One thing that's really cool is that, and another shout out to the GitHub provider, is that you could set up Vault and then create secrets and then push those up to GitHub for your repository, which is a really handy feature. For organizations, you can also push that up to the organization as a whole so that you can have like that global. I've got feelings about global variables, but if you need them, like if you're doing something like organization name or something, granted, there's easier ways to do that, but if there's something that makes sense to store at that level, you have the ability to do that, which is really helpful.
And I think the Vault flow you mentioned there is really, really good because it essentially, and it doesn't have to be Vault, any tool that can manage your secrets without you having to know about them, but having the tool in a position to provide secrets to something like Terraform is great, because at that point, you essentially become secretless as a team. And I know this sounds very marketing-y, like serverless, because there's still secrets, there's still servers, right? But if you and I don't know about the secrets and just our secrets manager does, that's perfect. Because what I don't know, I can't tell. And I also don't have to worry about it. Also means if we're pulling that from a secrets manager, we can update it there and our Terraform code will keep working. And I don't need to have another piece of updating. Very much the same workflow that we have with having Terraform generate Packer files. Very much the same way we have Terraform look up dynamically the Packer image. It's all meant to make it a little easier and to have less friction between various moving parts. And I absolutely realize that's a very long answer to a very short question, but security is something that requires multiple layers.
It's really true, and it's always something to be mindful of. It's best to start that process, day one. It's security's never best. You can do it, but I advise strongly against that. Start thinking about security from day one. Don't let perfect be the enemy of good. Things do still have to work. Sometimes there are security requirements where it would absolutely stop you dead in your tracks, and there's a better way to go about implementing it. Doesn't mean that maybe the second pass you can kind of implement that. You can always iterate with infrastructure, and infrastructure is code. But it reminds me of a great book called The Phoenix Project. For those of you who haven't read it, I absolutely recommend it. They kind of talk through some issues there where in this fictional company they go through a situation where somebody implements some encryption, and then unfortunately all the systems stop working because everything's encrypted and they can't decrypt it. So really, really good example of when that might not be the best thing in production, but always think about security for sure.
Yeah, there's many moving parts, and I think a couple of the comments are really reflective of stuff that you encounter with a lot of teams, right? Verify Windows is saying security is a luxury to some DevOps teams. Just get it done yesterday. Of course, yeah. We never have the time to do everything perfectly and properly. And that's why we need to make the friction of doing it the right way as low as possible. For us, and I know we've said this before in the past hour, for us, GitHub Actions is part of that process. When I don't have to worry about format and validate, and it gets done for me, then that's perfect. Obviously, the best place would still be that we don't get a situation where format and validate actually bring something up because my code is perfect. But it's Friday, and my code definitely was not perfect. See, I'm not the only one with really secure passwords here. I like it.
I did want to give a shout out to Nico from Ohio, also from Ohio here, was born in Columbus, Ohio, then moved up to Cleveland, Ohio and lived there for a while. Now I'm out in Los Angeles, but always happy to see Ohio in the thread. Got to give that a shout out.
Same. Verify Windows has a great question. Would you use GitHub Actions as a deployment tool? So with a lot of these kind of questions, the answer is always, it depends. For anything where I'm 100% confident that the information that could leak is not important, I would say absolutely. It also depends on your organization. I know the teams running GitHub agents, both in GitHub E, obviously that would be your teams, and on github.com, it would be, the GitHub SRE team. They're making a huge effort to make sure your information doesn't leak. But you might still be in an organization that says you can't share your cloud credentials with a provider that's not approved. And that's really what it comes down to. For example, the first thing we showed you today was deploying GitHub repositories with Terraform and codifying them. So we're doing this in GitHub Actions against github.com. We're running the actions on github.com. And all we need to make that work is a GitHub token, which Actions have access to anyway. So what's our blast radius here? Practically zero. So absolutely, for that, no question asked. If we're talking about creating a cloud HSM, so a hardware security module, and making sure we can sign our PCI data with that, maybe not so much, mostly because PCI DSS, the standard, doesn't allow you to do things like that without a huge risk assessment. So the short answer is it depends.
and it does make, I can absolutely attest to, I missed in the comments where it was, but for any of you that don't like managing a Jenkins server or a machine, this is a really good workflow, and it does kind of improve that. Granted, it depends for your situation, of course, and it's always in some cases difficult to justify moving to a new thing, or when is the best time to move to a new thing. Newer isn't always better, right? And it can kind of it can really slow you down if the team doesn't say we have a build process and everything works. It might not be the best use of our time, and focusing on some other things. But I can attest for any of you that are interested in moving from Jenkins to GitHub Actions and can do so. It's really great for me in some personal projects and home lab stuff. It's made the process a lot easier, and it's a lot better and more visible too for other friends and family that I work on things with.
I think one of the comments was pretty nice in that it's an organizational problem, and that's really what it is.
Any other questions or thoughts? And granted, we love spending time with you here live. But if you do have any questions or things come to you after this session, feel free to reach out to Kerim or myself. We'd be more than happy to have chats with you and see what you're working on. Hear good, bad, and ugly. In terms of your workflows and code that you're writing, and if there's anything that you want to see from the Terraform or just infrastructure in general, in what landscapes.
Yeah, absolutely. I mean, we're here to answer these questions. We can also answer them after a stream. And these have been really good questions. When you think about a lot of these problems, talk with your counterpart from a company that you don't work with. Everyone is running into the same problems. Nobody has a perfect deployment. Nobody has a super frictionless security process, because none of these things are possible, but we can all learn from one another. If you need to define 18, 20 layers of security, maybe somebody has already figured out 6 of them, and you can copy that and essentially replace the private keys, and you're good. Yeah.
I like to follow them on Twitch, Twitter, LinkedIn, and MySpace.
Actually going to check my MySpace. Really hoping for a follow there. Other than Tom and Taylor, nobody follows me there. Very sad.
You're like, Tom too? Interesting.
I do.
Awesome.
Yeah, my GeoCities is definitely offline, but yeah, we've got a couple of really great links in terms of GitHub action guides that were popping up right now. All of this stuff can get complicated, because when you're building your image inside GitHub Actions, you need to think about, okay, where am I deploying it? Do my actions have access to that? What are GitHub's IP ranges? What other things do I need to consider? And then you bring in a tool like Terraform, and you can retrieve a lot of this and just have it run automatically for you. Good thing is, if you're just joining us, you're about an hour late to the party.
So sorry.
But everything was recorded, so you can watch it later.
One of the things that I see people do, people I've worked with typically have a lot of questions about Terraform and where does it fit into your the application development lifecycle. And I've seen some people kind of stick with one provider, right? They might use a major cloud like AWS, Azure, GCP, and then only for that. But as you've seen today, we can do a lot with GitHub Actions, with Terraform. We set up a GitHub repository with Terraform, which is incredible. We spun up a machine. We built something with Packer. We used HCL all over the place. There's a lot that can be done and a lot of things that you can string together. But that does make it confusing on places to start, because when you think about configuration management, I've seen some people try and trend that direction and use Terraform to also be configuration management. Terraform works really well in a declarative sense, right? And so if you're doing a blue-green deployment, that might work better for Terraform. But if you're trying to modify something in place and keep configuring it, it can get a little bit messy. Terraform has really nice tooling inside of it so that you can use, spin up new resources as you need. But if you're just getting started with Terraform, take a look at data sources. There's a lot that you can search for and pull down and use without having to, really do any kind of bash, black belt bash type scripting or anything like that. You can just use a data source, and it's really, really helpful. I'd say that was a more harsh learning experience for me as I got started with Terraform back when it first came out. Data sources are really a wonderful thing.
Yeah, and they've been growing a lot. One of the things we just mentioned, IP ranges, when you're doing remote deployments, a lot of the providers that Terraform supports actually have data sources that allow you to retrieve specific IP ranges. And what's super cool about this is, let's say you're running your GitHub Actions agent locally because you want to utilize all the formatting and validation tools remotely, but the actual deployment needs to happen on your network. Cool, run a local agent. But now, do you really want to open up your local deployment tool to the world? Of course not. So one way to get around that is to retrieve GitHub's IP ranges through Terraform and then use that to open up your firewall. Taylor mentioned Azure and Google and Amazon, but you might be running a local firewall that has an API. Very likely, Terraform will know a way to interface with that. And that's Friday bliss for you.
Well, we hope that you enjoyed the stream, that you enjoyed our Friday deployments. Please check out the repository if you haven't. If you do want to follow along and check out those GitHub Actions, don't be a stranger. Feel free to reach out and talk to either of us. And with that, Kerim, do you have any closing words?
Yeah, I noticed two really cool questions. Getsums, do you guys deploy to prod on rolling basis? It's kind of personal. It's not personal. It's only personal when the rolling basis doesn't work out. Then it's definitely no. I'm sorry, I can't tell you. Where it makes sense, yes, because the gatekeepers should be automatic, and you should have tooling in place that feels comfortable to say yes, this is good, or no, this isn't good, and also be very restrictive. Not every PR has to end up being on main and being a deployable version. Sometimes, you're just exploring. And the other closing word is literally that: keep exploring. It's been a hard year for a lot of us with not being able to go places, but that doesn't mean that the learning has to stop. Conferences might not be here, but cool streams like this one are. And you get to learn from other people. You get to see other people make mistakes. Think about what you can show others. It goes multiple ways. Show your local community, hey, I learned this cool thing. And maybe, you'll create a community of your own. I think with that, thanks for having us. And we'll see you next time.
Adios, everyone.